Hi there, I'm Mrs McTaggart and this is lesson 1 in the higher maths topic of circle. So we're going to look at the most original circle, which is a circle that has a centre of 0, 0. So to explain where the equation comes from, I'm going to show you this illustration here. So I've got a circle with a centre 0, 0 and I know that one of the points on the outside of this line is 3, 4. So the question is, how would I find the radius, this line that's drawn in here? Well, think about how you plot the coordinate 3, 4. If I make this into a right angle triangle, you would go along 3 and up 4 to plot this point. And to get that distance r, you would say, well, r squared equals 4 squared plus 3 squared, which is 16 plus 9, giving you 25. So r is the square root of 25, which we all know is 5. Now the actual equation of this circle is what you have just done there to get the radius. You did your x coordinate plus your y coordinate squared, and you came out with your radius squared. So it's actually just a little extension of Pythagoras there. The equation of the circle is based on getting that. And this is only if the circle has a centre of 0, 0. So the actual equation of this circle would be x squared plus y squared equals 5 squared, which we're going to write as 25. So there's just a little bit in yellow for you to remind that the general equation of a circle, as long as it has a centre 0, 0, is this x squared plus y squared equals r squared. This does alter when we start moving away from a centre of 0, 0, but for today we're just going to get into the habit of practicing this. So I've got a couple of equations of circles, and all we're going to do is write down for each one what the centre and radius is. This would be your starting point, just to familiarise yourself with it. So in fact, all these circles today have a centre 0, 0. And the radius, please remember, this number here is your radius squared, so you really have to square root it. So although this says 6 squared, that would really be 36, but we can just drop the squared, and the radius of this one is 6. On this one, they've actually squared what the number was, so this 144 is what r squared is. So r would be the square root of 144, so your radius would be 12. So this one has a radius of 12 and a centre of 0, 0. This next one doesn't fit the kind of mould, it's not in the right order. Well, it is in the right order, but it's got a 2 in front. The equation must be x squared plus y squared, but what we can do here is we'll just half all of this, and you get x squared plus y squared equals 25. 25 is your r squared, so r would be the square root of that. So we've got a centre 0, 0 and radius 5. That was actually the one I used in slide 1. And then this one again, it's just not in the right layout, so I'm going to bring that x squared over and have x squared plus y squared equals 16. So the centre is 0, 0. Remember that 16 is r squared, so we square root it. Our radius is 4. Okay, so the next little bit is doing it in reverse. I've told you the centre, I've told you the radius, we want to get the equation. So the equation of this one is simply x squared plus y squared equals your radius squared, so 11 squared. And then we'll just rewrite that again by actually working out 11 squared as 121. Similarly with this one, we'd have x squared plus y squared equals, now it would be root 3 squared. And remember, if you do root 3 squared, that's just root 3 times root 3, which gives you root 9, which is just 3. So the square root and the square essentially cancel out. So watch out for that one. X squared plus y squared equals 3. Okay, so here's an example. We have to find the equation of the circle with centre 0, 0 passing through the point A, negative 8, 6. So what we have to do is, if we picture this, our centre would be here, and which is obviously 0, 0, and the point negative 8, 6 would be something like this. So we're going back 8, up 6 to get a radius. We're going to do Pythagoras. So our radius squared equals 6 squared plus 8 squared, which is 100, 36 plus 64, hopefully you recognise this, and the square root of 100 gives you 10. So if my radius is 10, centre 0, 0, my equation is simply x squared plus y squared equals 10 squared, and then to write that out, x squared plus y squared equals 100. So that's the equation of the circle. Okay, I have a couple more examples. This one we have, find the equation of the circle, centre 0, 0 passing through 5, 2. So that's just the same as what we did before. We're going to draw a little picture to help you imagine what's going on. 5, 2 would be a long 5 and up 2. And then we'll get a radius, so we'll have radius squared equals 5 squared plus 2 squared. So my radius squared is 25 plus 4, so 29. This time it's not a nice number, so we're going to leave it as root 29. Then it says, does the point negative 4, 8 lie inside, outside, or on the circle? So what I'm going to do is I'm going to find the distance from the centre to this point, negative 4, 8. So the distance will be, and if you remember the distance formula, you can do x2 minus x1 all squared plus y2 minus y1 all squared. However, we are just working out the distance from 0, 0 to minus 4, 8 again. So it's going to be the square root of minus 4 squared plus 8 squared. Let's create a wee bit more space. Which is 16 plus 64, which is root 80. Now, because root 80 is greater than root 29, the point lies outside the circle. If it lay on the circumference of the circle, it would be exactly the same as your radius, but this one is bigger than the distance to the radius, so it lies outside. You can also simply plug in the numbers to the equation and see if you come out with 25. So if you plugged in 4 squared plus 8 squared, you're going to come out with 80. It won't give you the 29 for the radius, so that's what we do for that one. So it lies outside. If my number had been less than root 29, then it would have been inside. Right, my last example, point P. So we've got point A, P2, find P if this lies on the circle. Right, so I have given you a point, P2, and I've said it lies on the circle. So if I plug in x and y as these two values, it should equal 7. It should do what's called satisfying the equation. So, remember, whenever we give you a coordinate, you've got a value of x and y. So that's what we're going to do. So we're going to replace x with p, so p squared, plus 4 squared equals 7. So we've got p squared plus 16 equals 7. Subtract 16 from the other side. So 7 take away 16 is, I've gone completely blank. That's 9. So p squared equals 9. So p is the square root of 9. But just remember, there's two values for p. P can be, it can be negative 3 or it can be positive 3. So p is plus or negative 3. Alright, so A, if I wanted the coordinate, A could possibly be 3, 2, or A could be negative 3, 2. It didn't ask for that, just wanted value of P. So just remember, when you square root, you can have two possible values. And that's the end of that video. I hope this has helped. This is just a start. There are 7 more videos on the circle topic. Thanks for watching. Bye-bye.